It's weird how something as simple as a hologram, like you see one, and it just sparks all these huge questions, right?
Hmm.
I remember when I was a kid, I was so mesmerized by those holographic stickers.
Oh, yeah,
It just like felt like magic, you know?
totally.
And then suddenly we're talking about the entire universe possibly being a hologram. It's like, whoa.
It kind of really stretches the imagination, doesn't it?
Yeah, for sure.
But what's amazing is this isn't just like some science fiction thing. The holographic principle is a real deal in theoretical physics.
Right, right.
Like it all stems from how we understand black holes and even string theory.
Yeah, and that's actually, we've got Wikipedia excerpts from BBC Science Focus magazine, Discover magazine. We're trying to put this all together.
A lot to unpack there.
A lot to unpack. So to get us started, can you just break down very basically this concept of the holographic universe? What are we even talking about here?
Okay, so picture this.
Mm-hmm.
Everything we see and experience, like in our 3D universe, like every galaxy, every star, planets, even us,
Yeah.
it's all just an expression of information, but encoded on a 2D surface.
Okay.
It's kind of like, those holograms
Yeah.
where a flat surface projects a 3D image?
Yeah.
It's kind of like that.
Okay, so instead of everything around us actually being real in the way we think about it, it's more like a projection from, like, I don't know, some kind of cosmic blueprint.
That's a great way to put it, yeah.
Okay.
And this whole idea, right, about information being so central to what reality actually is,
Yeah.
that's where things get really, really interesting.
Yeah, okay.
And a key figure in all of this is this physicist, Jacob Bekenstein. Back in 2003, he asked this question, and it almost sounds philosophical when you hear it.
Okay.
He said, could we see a world in a grain of sand?
Whoa. That's quite a thought.
It's a mind bender, right?
It is.
Yeah.
How does that tie into all of this?
Okay, so Bekenstein, he was making this parallel, right? Between, like, the massive amount of information packed into just a single grain of sand.
Yeah.
Like, think about it, the arrangement of atoms, its entire history, everything about it.
Right, right.
And he's saying maybe our universe's information content, it could be, like, similarly contained on a surface,
Sure.
Like just how a hologram takes all this complex info and puts it onto this simple flat surface.
Right.
Maybe our universe's info is also encoded onto some distant surface, something that represents its boundary,
Okay, so instead of our universe's information being, like, contained within its volume, it's more like it's all inscribed on this distant boundary, even if that boundary exists in a way we can't even really imagine.
You got it.
That's wild.
It's a wild concept, and that's actually where the whole black hole thing comes into play.
Okay.
Black holes, they're so strange. They had this crazy relationship between their entropy and their surface area.
Okay, hold on. Let's unpack that a little bit. Because we hear entropy, right? And usually it's like, oh yeah, entropy, a measure of disorder. But you're saying it's also deeply connected to information.
Exactly. You're spot on.
Yeah.
Entropy, at its core, it's a measure of, like, all the possible arrangements in a system. So the more ways you can arrange things, the higher the entropy.
Okay.
And what's wild is that the amount of info you need to fully describe a system, it's directly tied to its entropy.
Oh, interesting.
Think of it like this.
Okay.
You have a really organized library, right? Low entropy.
Okay.
Only a few ways to put those books, so it's considered organized.
Right.
But then you totally trash the library, right? High entropy. Books everywhere.
Yeah. Cave.
Total chaos. And to describe that mess, you'd need way more information.
Okay, so more entropy equals more information. Got it. But how does this bring us back to black holes?
Right, so black holes are mind-blowing because their entropy, and therefore the information they contain, it's not about their volume. It's proportional to their surface area.
Oh.
Yeah, it's crazy to think about because it's like saying everything that falls into a black hole, all the info about those objects, doesn't disappear. It gets encoded on the event horizon.
And the event horizon, that's like that point of no return, right? At the edge of a black hole.
Exactly. It's like, imagine the event horizon as this cosmic movie screen. It's displaying all the information of everything the black hole has ever swallowed.
Wow.
And this idea that a region of space can have its info encoded on its boundary, that's a huge part of what led to the whole holographic universe concept.
So are we saying that, like, if the information about everything inside a black hole is encoded on its event horizon, does that mean, like, somewhere out there, there's this gigantic sphere surrounding everything and all of our universe's information is, like, plastered on that?
Well, it's a cool image, but not quite right. You see, we don't actually know if the universe even have a boundary the way we typically think about it. The holographic principle just suggests that the information about it could be on some lower dimensional surface, but its nature, where it is.
Yeah.
Those are open questions.
Okay, so maybe surface is kind of misleading. It's more about the information being confined to a lower dimension than what we experience, even if we can't, like, point to it.
Yeah, exactly. It really messes with how we think about space and dimension. And get this whole holographic universe idea, it grabbed the attention of Stephen Hawking himself.
This was his final theory, right? The one with Thomas Hertog. What were they looking at with this holographic universe stuff?
So Hawking and Hertog, they took this idea and they ran with it. They said, what if time itself, something we experience as this straight line, always moving forward, what if that's also holographically encoded?
Whoa, wait. Instead of the universe existing in time, time's just another part of the hologram.
You got it?
My brain's hurting. Okay, so what would that mean for something like the Big Bang?
That's where it gets really interesting. Hawking and Hertog basically said, if we're looking at the universe holographically, the Big Bang might not just be the beginning of the universe, but the beginning of physical laws, of time as we understand it, you know?
So it's like asking what's south of the South Pole. The question doesn't even make sense because in this way of thinking, time didn't exist the way we know it before the universe's hologram started projecting.
Exactly. They were saying that as you go further and further back, closer to the Big Bang, our normal ideas about space and time, they just break down completely. They use the term fuzzy to describe that state where the universe wasn't following the same rules it does now.
Okay, so we've got black holes with information on their event horizons, a universe that's maybe a projection from some higher dimension we can barely understand, and time itself is part of this hologram. It's fascinating, but how do you even prove any of it? How do we go from cool theories to actual science?
That's the million-dollar question. Observing something like the universe being holographic directly, it's crazy hard, especially with what we have now.
I can imagine. We can't just, like, fly a spaceship out to the edge of the universe and look over the side.
Not yet, at least. So for now, we rely a lot on math, on these thought experiments. Even Hawking and Hertog, they called their work a toy model, admitting it has limitations. But some physicists think we might find indirect proof, something called holographic noise.
Okay, holographic noise.
Yeah.
What is that?
Remember how we were saying the universe's information might be on that distant lower dimensional surface? Something that would actually create tiny fluctuations in space-time itself, like a quantum jitter, a little sign of that deeper holographic structure.
So like a cosmic fuzziness to reality. But if it's so tiny, how could we ever even detect that?
It's tough, for sure, but, it might not be impossible. We've already got things like gravitational wave detectors.
Right.
And those things are nuts. They pick up these tiny, tiny ripples in space-time, and we're talking events from, like, billions of light years away, black holes colliding.
It's mind-blowing.
Total mind blow. But the thing is, some physicists think that if we can make those detectors even more sensitive, they might, just might, be able to pick up holographic noise.
So we could be using the same tech that lets us listen to black holes crashing together to also peek into the fundamental fabric of reality.
Exactly. It's all connected. Even if we never actually see this holographic projection directly, just finding something like holographic noise would be huge. We'd know something really funky is going on way down deep,
Yeah. It really makes you think, like, these crazy ideas pushing the edge of what we can even comprehend, we might actually be able to test them.
That's the beauty of science, right? Human ingenuity. But even if we don't find, like, concrete proof of this holographic universe thing anytime soon, just thinking about it changes how we understand ourselves, our place in all of this.
I'm with you on that. For me, just trying to wrap my head around it, it's already shifted my perspective. Like, what if reality is so much weirder and more beautiful than we can imagine?
Totally. It forces us to ask the big ones, right? What is reality? What even is time? What is information? Those are questions that physics alone can't answer. It's philosophy, spirituality, our sense of self, all of it.
Big questions. So for our listener who sent us on this wild ride, how do we even begin to sum up something as huge as the holographic principle?
It's a lot, right? But here's the thing. It's still a theory, yes, but it's rooted in solid physics. It's a challenge. It's saying, hey, what if the universe isn't what you thought? What if it works in ways you're just starting to glimpse?
It's like we're standing on the shore looking out at this vast ocean and we've only dipped our toes in the water. Who knows what we'll find when we dive deeper?
Exactly. And maybe, just maybe, we'll find out we're living in the reflection of a giant cosmic hologram.
And if our minds weren't already blown enough, I think that's the perfect place to leave it, that sense of awe, of mystery. The universe is full of surprises, and we're just trying to keep up. Thanks for joining us on this deep dive. Until next time, keep those questions coming.